Well, welcome to this lecture series. Today we're going to be talking about a phenomena that happens throughout the desert, and it's very important to be aware of, and really it's a fairly easy situation to actually spot once you know what to look for, but it's quite another thing to start to understand how important it is to understanding the desert. And this is what we're going to try to reveal in this particular lecture. So let's get started. The particular thing we're going to talk about today is the difference between a north slope and a south slope. Many skiers know the difference and know there's quite a difference. That later in the season the north slopes are still have a lot of snow on them and the south ones are completely bare. Well, this phenomena happens in the desert as well, even though you don't have the snow there to contrast it, or oftentimes you don't. Sometimes we do have snow in the desert and it does make a difference. But the difference in the desert is that there's so little water that the evaporation of water is one of the crucial components to understanding the desert and where there really is water or there isn't. And so let's start with a real simple hill or mountain, and we have this shape more or less if we're looking on it endwise. And we'll have the sun up here. And of course in our deserts, our northern deserts, of course it depends on the latitude, but the sun is at an angle. And the angle is such that if this is the north side and this is our south side of our mountain, the sun's rays as it comes down are spread out on this side, and they're concentrated on the south. And another way we can kind of examine that, if you had a flashlight and you had this light at an angle and shining down on this slope, you'd find that maybe it takes in an area something like that. But at the same elevation above on this slope, it would have a much smaller area that light energy is focused on. And that's the key to understanding what we're talking about, is that the radiant energy, the light energy coming in from the sun has a lot of power. Some days it's as high as 1,000 watts per square meter. That would be, if you want to use yards, about the same. That would be like having 10 100-watt light bulbs on a fixture, say a yard square, and putting it right over a piece of ground. That's the kind of light energy that we're getting from the sun. It's a tremendous amount of energy. And that energy, of course, drives the whole biosphere. But in the desert, because water is such a crucial element, it often works against life. And so let's start looking at what it might do. If we get a rain, and let's say it rains on this entire mountain, and incidentally, I guess we should discuss this first, that the scale of this can vary tremendously from something this small, literally, a small berm on the road. If you look at a north-south berm on the road, that is a berm that's actually going east-west, and you look at the south side versus the north side, if it's been there for a couple of years, you will find that this side will be relatively dry and this side will have tall grass, just a few inches. And if you go to a mountain that might be 5,000–10,000 foot, especially one that's a hogback ridge, you'll find that phenomenon starting at the very ridge and working its way entirely down the mountain, thousands of feet down. The difference between the north and the south is going to be different. So the variation in size doesn't change the phenomena. It just changes the intensity of it. But of course, if we use this scenario, we say, okay, the berm on the side of a road may have been there a year or two, maybe 5, maybe 10 even. But if this phenomenon is taking place on a mountain, you have an extreme depth of time, thousands and thousands, even hundreds of thousands of years. And that begins to change things, because what you have on this side, because you have more growth, you have more roots in the system that when the plant dies, they rot. When water hits this from a thunderstorm, the plants break up the velocity of the drops, so you don't get as much erosion, and you've got more leaf litter. The bushes tend to hold their leaf litter because they're breaking the wind, and this starts to cycle up on this side. Whereas on this side, quite the opposite is happening. You get a rain, the sun comes up, it focuses energy on this slope, and we can have a lot of energy. We might have, if this angle is correct, this 1,000 watts per square meter, and on this slope, because it's so spread out, we might only have 2 or 3 or even 100 watts per square meter. So the amount of energy available to evaporate that water can be, a factor of 10 or more. The change is tremendous. So these plants have never grown. Oftentimes you'll find something like pinon and juniper on this side and nothing but grass and scrub and sagebrush on this side, because the dryness is so intense that a different plant community takes over. It has that much difference. Now, because of that, the erosion on these two different sides change. You have different erosion patterns occurring on both of these. And if we try to clean this up a little bit so we can play around a little bit with erosion and not just plants. But of course the plants are affecting it. Here's our mountain again. Because there's nothing on this side, or less on this side, to hold back the forces of erosion. When water, a thunderstorm comes, it just hits the rock or the dirt or whatever it has and erodes it. If we were looking sideways, you're going to tend to find an erosion that's steeper, and when it hits the alluvial, it's flatter. That's going to be your tendency, but it's going to be steep, and there's something to understand about that steepness, where on this side it's going to be quite different. You're going to have a much shallower erosion and a much longer, steeper alluvial. That's just kind of the way the patterns, and of course the shallower canyon on this side is quite simply because the plants are hanging on to the ground and the roots are being held back, and all the way down the slope, all the way down. That situation where the plants are breaking up the velocity of the water, the roots are holding the soil, starts all the way down. So this is going to be less steep. It's just because the ground is being held. On this side, it's going to be much steeper. But what happens on this side is because those canyons become steeper and steeper and steeper and deeper, an interesting thing starts to happen. You get these deep canyons, and they themselves begin to have shade, in some cases permanent shade, because they've cut so deep that as the sun moves across, maybe only for an hour or two, is the sun able to look down straight into that canyon and put radiant energy down into it. And you can also get a situation, it's a little difficult to draw, but if you have a south slope here and it starts to cut, you can get feeder canyons back this way it'll have essentially a north slope. And that north slope will look oftentimes much like this north slope. So if you're coming up a canyon on the south side of a mountain, especially a large one, and you look back into a side canyon and you see that north facing slope, and you kind of get an idea on what kind of plant community is on that north slope. Maybe you see a pinon or a saguaro or something hanging in that north slope. Well, it's a good indication on what's on this side here. You can actually then say, well, if there's saguaros here, this north slope may also have saguaros on it. Or if there's pinon and juniper, then this larger slope over here may also be of that plant community. And so you start to understand how a mountain is working with the sun and the moisture, and how they play back and forth. And of course, you also get temperature extremes. The earth on this side can be 20, 30 degrees warmer than on this side. So with that temperature extreme, different animals are going to play out with that temperature extreme quite a bit different. For instance, a group of bighorn sheep might spend a good part of their day milling about feeding on this north slope. But if you've got a bitter cold night, there's a good chance they're going to come around and bed right up in here on that south slope. Why? Because that ground is actually noticeably warmer, and it makes a difference to their survival. As to whether they live or die may count on some days which side of the slope they find themselves on, where you can get, as many as 30 degrees difference. It's amazing sometimes the amount of temperature difference that you can find between one slope and the other. Of course, many times you'll find this side literally freezing the whole day. The ice doesn't melt, and this side has no moisture left, and it's all done. And that's one of the things you'll see with the north slope and the south slope, and the difference that they make to many of the different animals. The birds and whatnot will also follow this pattern of feeding on one side and staying on the other side for warmth during the day and the night, because again, that ground is going to maintain the heat, and they'll huddle right down onto the ground, and you'll find them oftentimes early morning still huddled to this side. Now, another thing that you'll find with the difference between these two slopes is it sometimes sounds like this, the south slope is just death, but not necessarily so, because if you remember the warmer soil and the warmer sun, a lot of times you'll get a winter rain in the desert, and on this side, essentially nothing happens. It's too cold. But on the south side, there's enough warmth that you start getting your small grasses and maybe your sagebrush and stuff like that has enough energy, enough thermal energy, radiant energy, to actually start growing and working. And you'll find that your animals that can reach this will do so. And it matters, of course, the scale of your mountain as to what animals. If it's a very small little foothill, you might have rodents actually working both sides of this hill. Where if it's a huge mountain, it might take something like our bighorn sheep or the deer or even the birds to actually be able to use and balance both sides to make their living. And this is one of the major components of any desert environment, and it's not that difficult to see and work out, and it's something that I hope you can find and see it and enjoy the way of things. And with that, I thank you.